Okay, and welcome back to the lab. And today here on the bench we have a Yaesu 817, which got too much supply voltage. So we do not really know how much it finally was, but it was a lot above 13.7 volt when it was connected to an external power supply. So then the owner recognized that it suddenly won't start up on an external power supply, but on the batteries he said it still starts up. So that sounds a little bit funny, because you know, normally it would be exactly the other way around, but anyways. So let's check what happens. Let's see if we can find exactly the same problem, and then let's go into that and let's see how we can fix it. Okay, and here is our FT-817, and you see here is the wiring for external supply. So radio is completely running on battery. So let's see how it turns out. Okay, so radio is starting up, and we have static, so that seems to be normal. Switch it back off and let me connect it to the power supply, and then let's see what we have then. Okay, and as you can see, radio is now on power supply, and we do exactly the same. We start or we try to fire it up, and let's see. Whoa! It's firing up without any problem. So that is already what we don't expect, because the fault description was completely different. So on power supply it would not start up, so but it does, as you can see. Well, so let's go and test some other functions. Okay, and what I'm really interested in is the question what is with our output power, so the transmitter, and the radio is set to maximum power, which should be 5 watt connected to a power supply, and that is what we have. And we see here an R on the display, which means that the backside antenna socket is in use. So yeah, let me simply press PTT, and well, you see the radio goes to transmit. We see it here on the red LED, and we see here PO. But there is definitely nothing on our power meter, so absolutely dead. And if you're following my channel, you know the game. So I have now connected the radio to our spectrum analyzer, since we do not see anything on our power meter. But as we all know, a spectrum analyzer is much more sensitive. So therefore I'm really interested if we can see something at least on the spectrum analyzer. Okay, and therefore radio is set to 14 megahertz, and of course the spectrum analyzer as well. And now let's go to transmit. Okay, and at least we see here a little carrier, which is already a very good sign. I mean, of course it is really tiny, minus 75 dBm, so that is almost nothing, and that is of course the explanation for that we do not see it on our power meter. But anyways, it is telling us a lot. So it is telling that the PLL, the voltage controlled oscillators, and the inner circuit in general is working, but well, we do not see a real output power, and that is totally different to what the owner has recognized. So absolutely the opposite, if you will. And since we know that transmit is not working really with the specified power, but we know that our VCOs and the frequency generation is working fine. So therefore now I'm curious if receive works, and I can say that receive is working fine. So you can hear the tone. You see here our bar graph, so that the S level is quite okay, and even when we watch the service monitor, all the parameters are fine, no problem. And before we go ahead, I have here taken out the battery so that we can check once again if it is working even without the battery. And it is, so it was not a kind of malfunction that the radio was starting up just because the battery was inside. No, it is definitely working on the power supply. So that is, as I already said, completely different to what the owner told us. Alright, but anyways, so the main problem I see here in the moment is that we have no output power, so the transmitter is not working, and therefore the first what we need to do is to crack the radio open and need to check what might have happened, and then we can go ahead. Before we go ahead and crack it open, let's do a reset, a complete reset, to be sure that there is nothing wrong here with the setting. So home and power, and let's see. Okay, so that is obviously our reset. Okay, so let's go back to 14 here to 14 megahertz, which we have. So everything seems as we had it, and let's see, but still no output power, nothing, absolutely nothing what we could see. So that reset does not change anything. So now it is the right time to crack the radio open. And here is our radio, and it really looks like that it has never been touched inside. And also here our final stage area, so which is covered by this foil here, seems to never has been touched before, which is a very good sign. But now, since we know that our amplifier is not working, we need to take here the foil off to get access to our amplifier, that we can start probing. Normally, if we have a radio which got too much voltage or got reverse voltage or such, we would see directly here in this area, we would see some burning marks or such. But here I really do not see nothing, which is again a good sign, but it does not finally explain what is or what has happened. And therefore, since we do not see nothing down here so far, yeah, we need to get finally access here to our power amplifier. And here we have access to our power amplifier board. And I mean, okay, the power amplifier is only this little board, so that is so that can be swapped by itself, so that is a module, and the rest here, so that is our output filtering and so forth and so forth. So what we need to know is if we get a supply voltage down here to our MOSFETs, and we should get power supply voltage at its drain, but there is nothing. And here's a feeding point to this little PCB. There is nothing. So for an unknown reason, we do not get power here to our amplifier board, and no, definitely nothing. So therefore, let me see, can we get but again, so we get bias on both transistors. When we press the PTT, we get bias, but we do not get any supply voltage here, nothing at all. So now we need to see where our power get lost. Okay, and what we need to know is where we finally lost our voltage. And what we know so far is that, yeah, we are here, of course, on the main board, and we see that we get here our external power supply in, and the radio is switched on, so we hear the static. And well, so we know that this connector, so let me go a little bit closer. So we know that this connector here is finally our supply connector for our power amplifier. And well, when we go here to our meter, so we see there is definitely nothing. So let's have a short look here into our schematic, and let me zoom it in here a bit more. And what we can see here is our external DC input, and we need to get over to our connector. But first, what I want to show you is that we are, well, you can't see it, hang on a second, there it is. So you see that we are working here on a circuit diagram with a lot number 75 and higher, okay? Because what we are working here on is the FT-817ND version. So that is a newer model. And secondly, it is a very high revision number. And only with revision or lot number 75 and higher, we have a additional component here in our circuit. And I suspect the additional component which I'm going to show you in a second. Okay, and once again, what we do next is we go through our circuit from here over our D1085. We go here over this filter here, and we follow along because we need to find our connector. And there we have to go up here, and what we see is that we have here a new protector. So that is not an easy ship fuse or such like we have it here. No, that is a modern ship breaker, if you like, which is very sensitive and very quick, and that is here in between our supply connector towards our final stage. And I suspect this new kind of protector, this ICP S2.3, which is a 2.3 amp breaker, if you like, and that is what we're gonna follow now on the board here. Okay, and so you should be able to see everything so far. So I'm going here to the diode, which we have seen, and you see there we have our voltage. Now I go behind the filter, and you see we have our voltage. Now I go to this little breaker, and I'm in front of the breaker, and it is fine. And now I go behind it, and you see there is the point where we lost our voltage. So input fine, output nothing. Okay, going down here on the board where we are. So again, you see here the filter, and here the caps, and here right beneath our connector you see this little ship SMD component, which is our breaker. And here we have our voltage, but on the other side not. So that means our breaker circuit is definitely open. So we need to see why that happens. Is it only because of the voltage, the higher voltage at the input? So that is what we get reported from the owner. So what we need to know is there maybe a short on our power amplifier board? And what we need to see additionally is if we get charging voltage here at this connector for at least our battery. So that is the battery we have seen, and what we need to know is if under external power supply do we really get charging voltage. That is something what we can see here. Of course, our battery, here's, oops, can't see it, sorry. Here's our battery connector, and of course, if it is not connected to a power supply, of course our battery needs to supply our circuit, and that is what we can see here. So the battery voltage goes over this diode and is then on the same trace as it would come from extern, okay? But on the other way, or the other case is, if we have external voltage here present, then of course if we go up here, so we want to get our battery charged, and you see that this digital transistor gets the information, okay, let's charge the battery. And therefore we have this, it's a kind of power transistors. So we have two, as you can see here, okay. And then if the charging process is in use, then of course we would get here our charging voltage over this diode, and then if we follow along, we see that then the charging voltage goes to our battery connector. And on the other side, we see that this diode here is blocking the incoming voltage, so that not directly the incoming voltage can charge the battery, because that is not wanted, of course. So therefore we have here our circuit charging, and here the transistor, and we can check if the charging process is working if we get voltage here at our 1083. So that is a test point 1081. And if we have voltage here, that means that here our charging circuit is working. And that is easy to test. So we go down to the PCB and finally check if we have voltage here at that diode, then our circuit is supplied from an external power supply. And on the board we can see it down here. So that is the diode which will finally supply our battery. And if we go here to the anode, and I'm on the anode, and here you see our voltage. So that is the charging voltage which is present down here at that test point. And of course we can also see our charging voltage directly here at the connector. So we see we have here our red wires, and when we go here to our connector, I can see the voltage coming up. So let me go once again down here to the connector, and you see we get our charging voltage, which means that finally our charging circuit is working, so that is not affected by the voltage hit. And now what we need to do next, because I do not directly replace the little breaker, I just want to know first if there is maybe a short on our PA unit. And that is something we can test with the ohmmeter. And of course my meter is set to continuity, and that is what we can hear when I go to ground. And now when I test here at our connector, you see it is open, which is of course good, because let me go and check for resistance, because that shows that obviously there is no short. Means that if we are lucky, our final stage has been protected by this little breaker, which is new. So we know that the older FT-817 had very often problems with blown final stage, and that is one additional protection for the finals. And therefore, if we are lucky, we have a still working final stage because of the little breaker, which really helps to interrupt the voltage to our final to protect it. And again, when I test here on our power amplifier the supply, we don't have a short, and that means we can try if we can supply it with a second power supply, just to see if our stage is entirely fine. My left power supply is now supplying the radio as we had it before, and I'm now preparing here the second power supply to supply only our power amplifier, which has been cut off, as we have seen, from the rest of the circuit. But therefore we do here some precautions, and I will not directly put 12 volt to the circuit, but before we start, I start here my overcurrent protection, and now I switch the power supply on. You see still overcurrent protection. And what does it mean? So we have seen that I have set the amp to 3 amps max, and I believe I can go a little lower, because we have seen that it was 2.5 breaker, so we set it to 2.5 as well. And when I now switch it on, you see we have our overcurrent protection switched in, and that means if we finally get a short to ground, so that is here my wire, okay, and it is switched in, and now when I short it here to ground, you see that the overcurrent protection is directly switching off our power supply. So that will protect, hopefully, our stage for not going bad, because we are trying to test it. So that is very important to have power supplies where you can set an overcurrent protection or an overvoltage protection, and that is exactly what we have done here. Okay, the radio is now switched on, so we hear the static, and what we can see is that the radio is pulling 390 milliamps, so that is the receive current. That is fine. And you see that here it is now connected, and I really just bring it up very slowly, and I go in 1 volt steps. Still my overcurrent protection is in, so no current so far, which is good. Okay, 12 volt. So now we have 12 volt present at our circuit. And if we go over to the meter and I go probing down here at our feeding point, now we have 12 volt at the power amplifier. And let me see if we have voltage at the drain. First drain, second drain. So yes, we have voltage now at our power amplifier. And now we can start a test. Okay, so we have definitely everything in view. So radio is on, and now let's try if we get output power. So you see when I press the PTT what will happening, and here we have it, 9.5 watt output power. Oh wow, so that is again a radio which has been tweaked to the maximum. So we all know radio should normally deliver 5 watt, and to tweak it that it puts out almost 10 watt is definitely not the best you can do to those radios, because you're really stressing the amplifier. And well, anyways, if you like it, fine, but I never would recommend to tweak it to the maximum. Anyways, what we want to see is once again, so we know that the radio is putting out 9 point something watt. So we are delivering 12 volt, as you can see. And now when I press PTT, you see that the power amplifier for itself is pulling 2 amps, and the rest of the circuit is pulling approximately half of an amp. So that means that everything is really fine here. So our circuit is still working, and obviously we only need to replace the little breaker. And once again, 9.7 watt. Okay, since we know that our amplifier is fine, so that is tested, we need to replace the component, so this little fuse, and then I believe everything should be back fine. And you see already all taped with Captain, and so we can go ahead. And I had to remove it off camera, since we really have here a very narrow space, so you can see it down here. And it was really critical to get even here with my micro tweezer down to the area, and not to, you know, damage something. So therefore, yeah, it is off, and now we have to replace a new component down there, and then I believe everything should be fine. Alright, so job is done, and we can now prepare the radio for our final testing, and then it can go back where it has to go. Alright, and we are back on 20 meter band, and as you can see, I've set it to FM, and looks everything quite nice so far. So let's go over to the tester. Okay, and here we have it. So you see I'm really feeding a very low level into the radio, so only minus 120 dBm, which is really a tiny signal we have here. But you see it is still performing very good with 16-17 dB synod, which is definitely fine. And if I go and increase here a little bit our level, you see how fast our synod improves, and how nice our signal is. And of course you can hear the tone. But now we are interested in transmit, and therefore let's go over to transmit. Yeah, and what you see here is 11 watt output power, so that is what I already said, that that is not really a good idea. But anyways, it is as it is. Interesting, on the other hand, is the current which will be drawn. So what you see here, so that is a receive current, 390 milliamps. And now when I go to transmit, and that is very interesting, so let me go to transmit. And what you see is with 11 watt, 11.5 watt, we already have 2.6 amps which the radio draws. And you know, the fuse which was inside here, our little radio, only have or had 2.3 amps. And that is absolutely fine as long as you do not try to get more power out of those radios. But when you increase the output power, here in our case to 11.5 watt output power, it is normal that then the radio will draw more current. So that is nothing which is wrong, okay? And if you only have a fuse which can handle 2.3, so you know you are above the level the little fuse can handle, and therefore the risk is very high that you blow the fuse. And I now believe a little bit that maybe the radio did not really get too much voltage, so it was in operation and maybe suddenly it died because the fuse was not designed to handle 2.6 amps. Therefore, now I have increased the level of the fuse just a little bit. So I have now a 3 amp fast, quick fuse here in our radio, just to have enough margin to deliver the current for the higher setting for, you know, the power amplifier. I do not really like it, but I know that a lot of operators like to have here more than only 5 watt, and therefore you have to improve a little bit, or it's not improve, you have to fit a little bit the design that even if the radio is tweaked to the max, that you know, the fuse don't blow. So as I said, I don't think that it is a good idea to push for the max, but we all know many are exactly doing that, even or because or especially these amplifiers are really able to deliver the power. So that is not the question, but you know, the heat dissipation is not sufficient. So the heat sink finally is struggling a little bit with that high power. So you only should really take an eye on that when you transmit with such high power. Okay, I have already tested 70 centimeter and 2 meter. Both is working in RX and TX, so that is fine as well. So I have changed the menu to the rear antenna, because factory setting is that the front is engaged, and I've set it now to rear antenna just to check if everything is fine as well, and it is, so no problem. And the last we really had to do is to align our reference frequency, so that has to be 22.625 megahertz, and you see it is 0.1 hertz, so 100 millihertz too low, which is fully in tolerance, because I've recognized that it was a little bit off when we were using the radio on the different frequencies. And to see what I'm talking about, so here is our ref unit, and what you hopefully can see is here is our ref crystal, and it is 22.625, and then it goes out to the circuit. And now that has been aligned, and everything is fine now, and we can put the radio back together. Okay, and our last pictures. So radio is now battery operated. So you see it is coming up, and what we can hear is that we have receive, and of course we can transmit, and yeah, everything is working just fine. And therefore radio can go back to its owner, and hope you enjoy it, and catch you next time. Bye.